These trees in the far north of these species really have a small period in the spring where they like warm temperatures. They respond in June. They need warm temperatures in June, and their major growth is determined in that short period of time, maybe just a couple weeks, 3 weeks in June. When there's broad flooding, June is cool in this area because the river floods so much that the water is taking in the energy of the sun, and it's not able to heat up the ground. So cool June air temperatures, flooding, cool June air temperatures, and narrow rings in these larch and pine. Then the other trees, which are poplar and willow that we sampled, those are riparian trees, and they're flooded to some degree every year. They like water. They're hydrophilic species. They respond positively to moisture, so they like flooding. So they're inundated every year, and in normal conditions or slightly wetter than normal flooding, they have wider rings than normal. So it works in the opposite way for these trees as these trees when flooding occurs. The riparian trees have a little wider ring. The non-riparian trees have their growth suppressed. I mean, this was our hypothesis going in. But from work Leonid had done in the past and looking at the rings, he also knew that in extreme flood years, really tremendous inundation for a long time, these riparian trees say, I've had enough. I mean, I can't take this, is too much. And they would sometimes be missing a ring, or they have very narrow rings. So this, or anomalies in their cells. So this is kind of what we're looking at with the riparian trees, and it's the continuing part of our research there. We've looked, the first part was looking at this signal that we get from the non-riparian trees. How does it know? it only knows after it happens that it's.
So because it's squeezed out what it's already absorbed? Is that why the ring is small?
No, it cuts down on its ability to get oxygen. The roots are starved of oxygen. That's primarily why.
So it's not magic.
No, it's not magic. No, there's no antenna there for that that it knows it by. It's a physiological response. This sketch just shows, this is the floodplain, say, of the Ob River. During a high flow year, there's water everywhere. So there are all sorts of these, you saw the one photo I showed with all these sloughs and these backwater deposits. With all that water, it absorbs the solar radiation. It doesn't heat the ground. With a low flow year, it's dry, except in the main channels. So the ground heats up, and the air, since the ground heats up, the ground heats the warm ground, then heats the air. This gives you warm June air temperatures, and the non-riparian trees like that for growth. This is kind of the idea. So the upland floodplain tree species we sampled were not subject to direct flood damage, and here's an example of a setting for one of these trees. And one of the species we worked with is Siberian larch. With this fluted, it's a deciduous tree, so it drops these needles in the winter and has this fluted base. Going along the river in the boat, I mean, you can spot these larches from a distance. The crowns have a very characteristic look, so we know, oh, there's some old larch in this. So this might be a spot to moor the boat for looking the next day. So a distinctive crown that you could see. When we would go into the woods and look at the larch, it was surprising how sometimes if you got far away from the river, a very small larch with a diameter like this would have 300 rings in it. And it would be older than this tree here, this big tree, the Leonid's quarry. And Leonid's explanation for this is that it may have something to do with the insulation of the peat up there that keeps the soil from warming up. And so that in general, the roots, it's very cold in general at some of these sites. So they never get the warmth they need, and they have a very slow background growth rate. Larch has been known to grow, I think the oldest one, around 750 years. So it can get very old. And larch from Siberia, this particular species and related larch species have been used. One of the key species in, you've heard of the hockey stick curve as part of the proof that there's been a rapid warming in the context of the last 1,000 years. So larch has been used for that. The second tree we used here, Siberian nut pine. Here's the crown. We would see these marks on it. I asked Leonid, what's up with that? Well, he said, this is because the native people go out in the woods, and they've done this for centuries, hitting the tree to knock down the nuts. And, you know, this guy was watching. Here's an example of the cones. They're not mature cones. A squirrel watching us there. But they would do this annually. It's a tradition that still goes on. The Russians will go into, when these nuts are getting ripe, and they'll go out and they'll harvest them. Back when they were building the Trans-Siberian Railway, the turn of the 20th century, actually one of the biggest products, Russian products, was Siberian pine nuts. And it still is a big export. China buys most of them. But they're delicious. I mean, I can vouch for it. I ate some of them. It's very good. On the other hand, we go down to the riparian tree species. So these are the ones near the river. They're subject to annual flooding. And there's a mud line that shows where the river had stayed up at a high level. And willow, other riparian species. These don't get as old, maybe 150 the max for the willow, so they're not going to get 700 years old. We would see these adventitious roots on the trees commonly, so if they're submerged a real long time, they'll put out these aqueous roots to try to get a little more oxygen. We used our data and we published a reconstruction of it based on the non-riparian trees. And we used this to get the flow record back to 1705, and we could show from, this is a curve of the river discharge from 1705 to present as reconstructed from the tree rings. And our main conclusion from that is the modern period does not have the extremes. There were big extremes in this flow in the past that were larger than in the present. But it's a weak reconstruction. It's got some problems yet. So we're trying to improve that with the riparian trees. And that's what we're looking at now. So in the path ahead, remember I mentioned that with extreme flooding, it's damaging to the tree. Well, here's a number of days. This is the number of days that the water level was above 5 meters on this measurement stick at Sally-Park. So this is lot, 5 meters, every year. The number of days every year. In most years, it's never above that. But in 1979, it was above that for 60 consecutive days. So this is the type of condition that would impact these trees negatively. And we're looking at this. We can see that growth is favored by wet conditions, but that reverses under these extreme long duration inundation. So we're looking at, Julie has been looking at this with taking slides of the cells, and I have an example if you want to come up later and look at one of these slides, and looking at what's going on in 1979, and you can see it here as a very narrow ring, suppression, with some distortion of the cells, but mainly it seems to be the narrowing of the ring. But we're still looking at this. The second topic that we would like to look at, and that was interesting on this trip, if you drive along the river, you see these peat banks where the river's cutting into where there was thick peat deposit from ancient forests and other vegetation. The peat lies on top of a clay layer, and Leonid says that where the peat meets the clay is about at the start of the Holocene, 11,000 years ago is his estimate. So that if you can find, and there's wood that sticks out of the peat. So he has made lots of wood collections. He has a lot collected in his lab, but he has not had time to analyze it. We would like to get together with Leonid somewhere down the line to look at that. So here's an example of some of the wood, sticking out of the peat. This is that right at the base of the peat layer, a piece. So you want to get a big log if possible. But he's got lots of samples to analyze, but his tedious work, and he's a busy guy. Third, the last point here, archaeological samples. As I said, it was not until after the 1500s that the Russians actually settled this area or conquered this area, and buildings started to build homesteads. And one of the earliest is in the 1700s. Leonid took us to this homestead here, about 150 miles from Yekaterinburg. We visited this. It was put together by a private citizen who moved. These aren't artificial structures, they're not replicas. He moved these structures from their original location, so they are actual dwellings. And here's a banya that I'm sitting by, and Leonid pointed out that you will never see logs this big in a modern structure, because when they built these structures, the forests were pristine. Since then, much of Siberia has been logged. In Soviet times, there was huge logging of the mountains and the areas along the river. So this is a potential to work with archaeologists maybe and also try to get some climate information from these old wood samples and structures. And finally,